For our last example in Chapter 19, we're going to suppose a patient's been told that he needs a kidney transplant and he wants to know the probability of surviving at least 5 more years. Surviving at least 5 years is a very common endpoint in public health. He is told that 90% survive the transplant operation, and of those that survive, 60% are successful, and the other 40% need to go back on dialysis. The proportion that survive at least 5 years is 70% for those with a new kidney that works, and 50% for those that have to return to dialysis. To state the probability model here, we already have it basically written above, so we're going to go ahead and organize it in a tree diagram right away. Again, try to draw the tree diagram somewhat to scale from what I'm doing so that it'll fit on your page. So the first stage of this experiment is having the transplant operation and surviving or not surviving the transplant operation. So we have 90% that survive and 10% that don't survive. So we'll call that D and S. Now that's going to be the first set of branchings for our tree diagram. I'm going to go ahead and draw a dotted line. Of course, if you don't survive the original observation, the tree diagram stops. If you survive the operation, then you either get a kidney that works or you have to go back on dialysis. So we're going to say W for kidney works and D for dialysis. It says 60% of those that survive the operation have transplants that are successful. So 0.6 is the probability for a kidney that works. And that would leave how much for a kidney that doesn't work? If 60% have a kidney that works, the other 40% have a kidney that does not work. Alright, so if you survive the original operation and you have a kidney that works, we can now move on to the last stage. If you have a kidney that works, the proportion that survive for at least 5 years is 70%. So we're going to call these two branchings +5 and -5 for surviving past 5 years or not. If 70% survive past 5 years, what's the percent that don't? That would be 30%, so 0.3. If you're on the survive the original operation, go back on dialysis branch, it says that 50% survive past 5 years. So again, you can either survive past 5 years or not survive past 5 years. And it's a 50-50 chance of either one of these options. Now in a minute, we're going to use these dotted lines to help us make some notes. So, if we want to do simulation, we've got to assign digits to outcomes. So we're going to go ahead and call this first partition stage 1, just so we have a name for it. The second one stage 2, and the third one stage 3, so we can assign digits. So stage 1 is either surviving or not surviving the original operation. And we said since we can write those probabilities out to 1 decimal place, 90% and 10%, then we're going to use single digits to simulate survival. So we're going to let 1 through 9 simulate surviving, and we're going to let the remaining digit 0 simulate not surviving. Stage 2 is the branching that denotes whether you have a kidney that works or whether you go back on dialysis. And the percentage that goes with the kidney that works is 60%. So again, we can go out to 1 decimal place when writing it as a probability. So we'll use single digit numbers, and we'll use the numbers 1 through 6. And of course, if you have to go back on dialysis, that's a 40% chance, so we'll use the remaining 4 numbers, 7, 8, 9, or 0. And now, we have two separate stage 3s. We have stage 3 with a kidney that works, and we have stage 3 with a kidney that does not work. In stage 3, if you've been on the kidney works branch, then the probabilities are 70 and 30%. So for surviving past 5 years, again, we can use single-digit codes, 3, 4, 5, 6, 7. And then not surviving past 5 years is the other 30%, so that's the last 3 remaining digits, 8, 9, and 0. In stage 3, when you were on the dialysis branch to begin with, your survival probability past 5 years is 50%. So we'll use the digits 1 through 5 to represent surviving past 5 years, and the other 5 digits, 6, 7, 8, 9, and 0, to represent not surviving past 5 years. Now that we've got all of our codes written down, we can go ahead and carry out the simulation. So again, we need to copy down some digits out of the table of random digits. So I have some right here, 59636, 88804, 04634, 71197, 19352, 73089, and 84898. Okay, so we start at stage 1 with our first code. Our first digit is a 5. In stage 1, a 5 means survive. So you survive the original operation. The next digit is a 9. We're in stage 2 now. A 9 in stage 2 means you went on dialysis. Stage 3, when you were in the dialysis branch, has a number of a 6 coming up. A 6 in stage 3 with dialysis means that you don't survive past 5 years. So one repetition is done, and this person did not survive past 5 years. Now we can do our next repetition. A 3 in stage 1 is survive. A 6 in stage 2 is having a kidney that works. An 8 in stage 3, when your kidney works, is not survive past 5 years. So again, we've got another repetition done, and it resulted in not surviving past 5 years. We'll do another repetition. An 8 in stage 1 is surviving the operation. An 8 in stage 2 is dialysis. A 0 in stage 3 with dialysis is not surviving past 5 years. So this is another repetition where the person did not survive past 5 years. A 4 in stage 1 is survive. A 0 in stage 2 is dialysis. And a 4 in stage 3, when you were on dialysis, is surviving past 5 years. So this one resulted in survival. A 6 in stage 1 is survive. A 3 in stage 2 is a kidney that works. And a 4 in stage 3 with a kidney that works is surviving past 5 years. A 7 in stage 1 is survive. A 1 in stage 2 is having a kidney that works. And a 1 in stage 3 with a kidney that works is surviving past 5 years. A 9 in stage 1 is survive. A 7 in stage 2 is going on dialysis. And a 1 in stage 3 with dialysis is surviving past 5 years. A 9 in stage 1 is survive. A 3 in stage 2 is having a kidney that works. A 5 in stage 3 with a kidney that works is surviving past 5 years. A 2 in stage 1 is survive. A 7 in stage 2 is dialysis. And a 3 in stage 3 with dialysis is surviving past 5 years. A 0 in stage 1 is not surviving the original operation. So this repetition is already over. This person did not survive past 5 years. An 8 in stage 1 is survive, a 9 in stage 2 is dialysis, and an 8 in stage 3 with dialysis is not surviving past 5 years. A 4 in stage 1 is survive, an 8 in stage 2 is dialysis, and a 9 in stage 3 with dialysis is not survive. So now we can get an estimate of our probability. We did 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 repetitions of our simulation. So the estimate of the probability is something over 12 repetitions. And how many resulted in surviving past 5 years out of our 12? It looks like 6 of them did. We have 6 pluses and 6 negatives. And so our estimate is 0.5 or 50%. So a 50% chance of survival. But we can compute the true probability. Let's go ahead and take a look at the tree diagram again. Again, we know that we're going to need to look at the paths that lead to the event of interest. And what is our event of interest? We want to know the probability of surviving at least 5 years. There are 2 paths that lead to surviving past 5 years. The first one, I'm going to draw in blue right here, is surviving the original operation, having a kidney that works, and then surviving past 5 years. So this first path results in surviving past 5 years. And the way that we can compute that intersection, that is, the probability of surviving the original operation and having a kidney that works and surviving past 5 years, again, when we have the word and, we want to compute intersections, we multiply up the branches. So it's 0.9 times 0.6 times 0.7. And that turns out to be 0.378. And the other path that leads to surviving past 5 years is surviving the original operation, going on dialysis, and surviving past 5 years. So the other way to survive past 5 years is to survive the original operation and go on dialysis and still survive past 5 years. And again, to take care of the word and, compute the intersections. On a tree diagram, we just multiply up the branch. So it's 0.9 times 0.4 times 0.5. And that ends up being 0.18. So now we can compute the probability of surviving past 5 years. The probability of surviving past 5 years is either surviving the original operation and having a kidney that works and surviving past 5 years, or, and remember the word or means to add, surviving the original operation and going on dialysis and still surviving past 5 years. And we've already calculated these 2 probabilities, this blue one and this green one, and that's 0.378 plus 0.18, which is 0.558. Again, even though we only did a few simulations, our estimate of 50% came pretty close to the true probability of 55.8%, or the true chances of 55.8%.